Throw your hands in the air if you's a true
DC motor.
So most of our frame was laser cut. We created all the models in SolidWorks, converted them to PDFs, and then laser cut them over there. We wanted to make certain features so that the build was nice and smooth during operation. We had these little magnet holders with open ends so that we could easily slide the magnets in and out. We also made bearing holders for bones red bearings so that we'd have less friction. And then we supported the bearings with wooden stints as well as washers just to make sure that they don't fall out while the motor is spinning. And finally, we also included a little hole so that our brushes could go touch the commutator and then also come out and attach, and we'd be able to attach the leads to them.
Excellent.
Okay, so the first part we made was this little rotor which holds all of the windings. As you can see, it was 3D printed from a file we made in SolidWorks. We did a series wind, which you can see because we have 320 degrees from each other. And we were originally going to include the commutator in the same piece, but that didn't really work out. We tried to do fewer windings because originally we were going for speed. So as you can see, there aren't that many windings here, but we still wanted to have enough to make sure it could start with its torque. Again, in retrospect, we probably should have made this much lighter, so it would have required less starting torque, and then we could have done even fewer windings and gotten a better speed.
So our commutator, as to be initially said, was part of the PLA 3D printed piece, but that didn't work because of adhesive problems. So we constructed an additional wood one, which worked well. We used copper tape for the conductive element, and we used an X-Acto knife to extract the copper tape and create patches where there's no conductivity. Another part of the setup was the brushes. We basically just used heavy gauge wire for the brushes. We found that these provided the best electrical contact and also had pretty small friction, so it didn't slow down the rotation of our rotor too much. Important thing to note is this popsicle stick rubber band configuration here. It allows us to increase the contact with our lower brush to the commutator, which we found to be a problem over a number of trials. As we would turn off and on the motor, because of the positioning, the brush would become increasingly warped, and by like the fifth or fourth time we turned on the motor, it wouldn't start at all. So this problem increases contact and mitigates this problem.